Imagine a world so distant, so alien, that every grain of dust might hold a secret to life itself. On March 24, 2025, NASA's Curiosity Rover whispered a new chapter in that story. Deep within a Martian rock, it found something extraordinary, the largest organic molecules ever detected on the red planet. Decane, undecane, and dodecane. These carbon-based chains, stretching 10, 11, and 12 atoms long, aren't just chemical curiosities. They're a fragile thread connecting us to the question that's haunted humanity for centuries: are we alone in the universe? Organic molecules are the building blocks of life as we know it. Carbon and hydrogen dancing together in patterns that, on Earth, form the membranes of cells, the essence of existence. Finding them on Mars doesn't mean we've discovered life, but it does mean the planet might once have held the ingredients for it. This is a story of exploration, of patience, and of a rover that's been our eyes on a world 225 million kilometers away. Meet Curiosity, NASA's six-wheeled marvel. Since landing in Gale Crater in 2012, it's been on a quiet, relentless mission to uncover Mars's past. Gale Crater, a 154-kilometer-wide scar on the planet's surface, is no random choice. Billions of years ago, it cradled a lake, water lapping against shores, sediment settling into layers of history. Within this ancient basin lies Yellowknife Bay, a place so intriguing that Curiosity detoured from its climb up Mount Sharp to explore it. In 2013, the rover drilled into a mudstone called Cumberland, a 3.7 billion-year-old relic of that watery past. Scientists weren't sure what they'd find, but they knew this spot, rich with clay, nitrates, and sulfur, had the power to preserve secrets. Before we move on, if content like this sparks your curiosity, please like the video and subscribe to the channel to help support our educational mission. Thank you so much. The Cumberland rock sample is more than just dirt. It's a time capsule. Inside Curiosity's sample analysis at Mars Instrument, or SAM, that sample finally revealed its treasure. SAM is a marvel of engineering, a microwave-sized lab that heats, sniffs, and measures the molecules locked in Martian rock. In earlier tests, it had found smaller organics, hints of carbon's presence. But this time, something new emerged. Through a refined process, scientists heated the Cumberland sample not once, but twice. First to 475 degrees Celsius, then, after cooling, to a blistering 850 degrees. This double heating trick, paired with a chemical agent, teased out molecules that had stayed hidden: decane, undecane, and dodecane. These long-chain hydrocarbons with their 10, 11, and 12 carbon atoms were the biggest organic finds Mars had ever offered. Why do these molecules matter? On Earth, chains like these often trace back to fatty acids, vital components of cell membranes, the fragile walls that cradle life. The team suspects decane came from undecanoic acid, undecane from dodecanoic acid, and dodecane from tridecanoic acid, fatty acids with 11, 12, and 13 carbons. Here, such molecules are forged by life, built 2 carbons at a time by enzymes. Intriguingly, the Cumberland sample hints at a similar pattern. Dodecane, with its even-numbered source, is slightly more abundant. But here's the catch. Fatty acids don't always need life to form. Geological processes like water mixing with minerals in ancient Martian vents can craft them too. This discovery isn't proof of life. It's a whisper of possibility, a suggestion that Mars's chemistry might once have danced close to the edge of biology. Picture Mars as it was 3.7 billion years ago. Gale Crater wasn't a dusty wasteland. It was alive with water, a lake stretching across the horizon. For millions of years, maybe longer, liquid flowed here, carrying the potential for life-forming chemistry. The Cumberland sample tells us those conditions lasted long enough to lock organic molecules into stone, shielding them from Mars's harsh radiation and oxidation. This find reshapes our hope. If life ever sparked on Mars, tiny microbes in a fleeting Eden, its traces could still linger, preserved in rocks like these. But Curiosity's instruments have limits. Sam can't see beyond 12 carbons, and the full story of these molecules lies just out of reach. This discovery is a bridge to the future. The Mars Sample Return mission, a daring plan to bring Martian rocks to Earth, could unlock what Curiosity can't. Scientists like Daniel Glavin, a co-author of the study, dream of studying these samples in labs with tools far beyond Sam's reach. We're ready to take the next step, he says, to settle the debate about life on Mars. But that step isn't here yet. NASA faces challenges, cost, design, time. Still, Curiosity's latest find stands as a testament to how far we've come, and a call to press farther into the unknown. Decane, undecane, dodecane, these are more than molecules. They're a call to wonder, a spark of what might have been. They tell us Mars isn't just a dead world, it's a place where the past still speaks, where the search for life presses on. Each discovery pulls us closer to understanding our place in the cosmos, to feeling the weight of a universe that might not be as lonely as it seems. So we listen, we wait, and we keep exploring, because somewhere in the silence of Mars the answer might be waiting too. Thanks for watching. Please take a moment to like the video, subscribe, and leave a comment. What do you think? Will we eventually find definitive proof that life once existed on Mars? And as always, remember, there's a whole universe out there, just waiting for you to explore it. See you later.